know already, I'm Deacon from University of Oxford, Experimental Psychology Department. So, if anyone ever needs any help in, for example, this or any animal behaviour problem, I'm always at the end of an email and I'm happy to give advice. But don't bring me your student problems or emotional baggage that I can't handle. Right. Can everyone hear me okay? Okay, well I'll try not to use the mic. How to write a scientific paper. This is probably the most important bit of advice I can give to a fellow scientist. I also prepared late last night some scribbled notes on how to give an oral presentation, which I'll do after a short break when I've done this presentation. If you don't publish, you will perish as a scientist. No one will know your name unless you produce papers. And the higher the quality of the paper, the better your name will become known, and the more likely your paper is to be cited. One of the joys of publishing is to receive citations, that is, other people reading your paper and quoting it as a reference in their paper. I had some joy last evening when I was preparing this lecture. I was trying to get an example of a paper off my own, off the web. Unfortunately, I'd forgotten my login and username for behavioural brain research, and they were demanding money up front in order to gain access to the PDF. So I am missing a slide demonstrating the layout of a paper. However, I did make note that two of the papers that I published in 2001 on the hippocampus and behaviour have each received over 100 citations since publication, and that gave me a really good feeling. So you can imagine the number of people who have read your paper will be at least 100 to every citation you have. So that means at least 10,000 people have read my papers, and that gives me a good feeling. So, publish or perish. How to write a good scientific paper? Essential to any scientist who wants to become better. The acronym for writing a scientific paper is WASP, which is a nasty black and yellow insect that flies around, tries to get onto your picnic in the countryside. It's especially fond of sweet things, and if you attempt to interfere with it, it will probably sting you. Ouch, it hurts. So, WASP, how to take the sting out of publishing, how to make it easier to do, less painful. And I couldn't resist quoting Muhammad Ali, Cassius Clay as he was at the time in the 1960s. Dance like a butterfly, sting like a bee. And I've incorporated one or two lines of poetry from the master of the English language, T.S. Eliot. This is taken from the four quartets, which to my mind are some of the most beautifully written works in the English language. I'm not a great Shakespeare fan, but T.S. Eliot seems to me to be a master philosopher, wordsmith, etc. And he wrote about the tribulations he had, the struggle he had with words. He succeeded, because I think his poetry is beautiful. But being a self-deprecating man, he wrote, "So here I am in the middle way, having had 20 years largely wasted. I spent 20 years at Oxford, so this is what I call trying to learn to use words, and every attempt is a whole new start and a different kind of failure. Because one has only learned to get the better of words for the thing one no longer has to say, or the way in which one is no longer disposed to say it. So many times you look back at what you did publish and think, I could have written that better. Luckily, that is becoming increasingly less frequent as I gain experience. So there's lots of publications describing how to write a scientific paper. Many of them excellent, but I've written a few notes here just to get you going. So I'm considering a formal scientific report. As a student, if you're writing up an experiment that you did in the lab, you should model your work on the style of the scientific report. Review papers, on the other hand, typically survey many reports from different authors, so details of method are subordinate to summaries of results, and you get a fuller discussion of the implications, perhaps emphasising a view to the reviewer. So one reviewer might write on the importance of 5H systems in behavioural inhibition, and you'll get an entirely different point of view from him or her compared to someone who thinks that 5HT is not involved in behavioural inhibition. So a scientific paper is a standalone document. The reason it is written is to allow independent replication of the work or to develop it further. It presents an account of a phenomenon or function that is crucially objective, testable, and potentially falsifiable. I like to approach the science that Karl Popper, the scientific philosopher, had. And he said, if you have a hypothesis, do not attempt to prove it. Try to disprove it. Your hypothesis will be so much stronger if you have made several attempts in different ways to disprove it. If it still stands up after all these attempts at falsification, then it is much stronger. But if the paper is wholly or partly wrong, it may still be useful. So, some papers closely follow the classical presentation of theory, generation of hypothesis, testing of hypothesis, assessment of the results, modification of the theory subsequently, and that generates new hypotheses to test. But in practice, science doesn't always follow such an ordered linear path. Work may be influenced by the availability of equipment, your individual expertise, and your personal view of the science, and the resulting papers will to some extent reflect this reality. Indeed, some of the most important discoveries result from pure serendipity, chance observations, dirty glassware, or even errors. Sometimes an experiment seems to go wrong. Experiments never go wrong. It's like computers. Garbage in, garbage out. So the style of writing the paper is crucially important. You should use the past tense and objective passive mode. This provides a uniform style and clarity. Now you might meet someone at the bar or in the bathroom and say, we go to those labs with a fairly high dose of compound X because we wanted to be sure it would work. But for a scientific report, this would be much better as rats were dosed with 50 milligrams per kilogram of X, as previous work, Peters et al. 97, had demonstrated significant inhibition at this particular dose. For any pharmacological presentations, especially to such a formal society as the British Pharmacological Society, you should use colloquial terms such as links with king. Apparently, I wasn't there to witness it, but there was a poor young student giving a presentation, her first ever, at the British Pharmacological Society's headquarters in London. And she said, we gave the rats 5 mg per kg of Yohimbe. And the chairman of the conference stood up and said, Miss Yvette, did you not know that a MiG is a Russian fighter aircraft? So keep your style concise, logical, and flowing. So don't present point B in the argument after point D. Your style should be flowing, linear, and logical. Make point A, then that gives rise to point B, and the implication of that is point C. Don't put C first before A. Put in all the facts relevant to an argument and make sure they link up logically. Don't present superfluous facts that are merely presented but aren't relevant or fully incorporated, because that will only confuse the reader and waste space. You'll notice T.S. Eliot's writing style is very sparing of words. If you could say in 10 words what someone else might say in 20, then it sounds so much cooler. So, make every word count. So, in most decent scientific journals, you have the paper arranged in the following order. Sometimes the order differs. For example, the proceedings of the National Academy of Sciences and some medical journals put the discussion first and put the methods and results in an ancillary section at the back. I prefer to keep to this logical style of presentation. As I said yesterday, I taught myself psychology. I'm a pharmacologist by training, and the reason that I got to develop a lot of new tests is that I read the methods section of papers, mainly the American behavioural journals in great detail. Read the methods in great detail, especially important in behavioural work, because in behavioural work, the devil is in the detail. I was teaching students some T-maze experiments this morning, and in the T-maze, shaped like a capital T, the mouse might choose this arm first. If you put it back, it's more likely to choose the other arm because it's novel. And to avoid, we had a large group cage of mice, and to avoid testing mice, which had already been tested, I said, put the mice into another cage once they've been tested. Could people please turn their phones on? My attention span and concentration is not very good, and I only had about 4 hours sleep last night because I've been making notes about how to give my oral presentation lecture. And when I got to the end of that, the final section was about how to combat performance anxiety and to prepare your body to be in the best shape for your oral presentation. That led on to further scribblings about relaxation techniques, and by 1 o'clock in the morning I realised I had the nucleus of a small book titled provisionally something like Simple Relaxation Techniques for Everyone. Okay, so the mice are going back into a little cage here, separate from the main cage, which is over here, and I said, place that cage symmetrically behind the maze, because if you put it here, the mice can hear their friends, they can smell them, and so they're more likely to choose this arm both times, and therefore your spontaneous alternation performance will go down. So it's important to read the methods section of papers in great detail to check all the little things which, from your past experience, you know might influence the behaviour. Many people these days, with time so precious, skip the methods section. And the thing I don't like about journals like Proceedings of the National Academy of Sciences, USA, is that the methods are often put into supplementary information. The methods are crucial to understand exactly what someone did, how you can replicate it, and how it might have influenced their results. Okay, so let's look at the sections of the paper in more detail. You start with an abstract, a summary of the paper. The essential thing to present is the result, set in its proper context and its implications. Choose the words carefully, particularly as abstract, rather than specified key words, are generally used nowadays in electronic information databases.
ابسط احترام للراجل اللي واقف بايدينا والجهود ده بصراحه ان احنا نركز معاه. معلش سوري ايه؟ I'm just telling them about the cell phones.
Sorry?
I'm just telling them about the cell phones. It should be heard of.
Yes. It's very disrespectful to a speaker to interfere with their performance. Be polite. Be nice. Right, so the introduction presents the background and the immediate context of the work. You set out the problems and therefore the questions to be asked, and you briefly consider how you will answer these. Ideally, even a non-specialist should be able to follow this presentation. You make references to recent and relevant work. You clearly set out the aims of your work, and the perspective of the present authors will provide a context in which the work is presented. The methods, as I said, are a detailed account of how the results were obtained, and they are crucial because if you give the methods in full, you are working in the UK, some scientists in Japan to try and replicate your work. Can't bother. You must allow people to attempt to falsify your experiment. If they get the same results as you do, then they have proof that you, for one, did not make the results up. I've been involved in several cases in which, to put it extremely politely, the behaviour of the rats was not crucial in determining the results of the paper. In fact, the first job I had at Oxford was to try and replicate the results of a previous student, and as the story began to unravel and more evidence accumulated, it became obvious that this guy had simply made up the results. It's a lovely story to tell in detail, but I don't have the time here. Suffice it to say that when he alleged he was working on the rats, he was in fact with his girlfriend in Birmingham. And he published his work, and it got accepted in a very reputable journal, to their shame. It should have been more rigorously reviewed. And one way, especially in behavioural papers, of seeing if the results are genuine, is to look at the variability. In other words, if you have a graph like this, and the error bars are very small and uniform, suspect the verity of the result. I was sent a paper to review. It had been written by some Indian authors, and the error bars were extremely small, and therefore the rats were behaving in a very consistent way. Well, rats don't behave in a consistent way. They vary. Behaviour is notoriously variable. And that's why people like me are in a job, and especially psychiatry. We have problems in society because there is variability in behaviour. We have criminals, murderers, child abusers, paedophiles. Their behaviour is varying, it is deviant from the rest of the population, and this causes people problems. I'm afraid that the person who falsified this data from Oxford and published this paper now holds the chair of psychology in a UK university. And it is just appalling that the academic system cannot weed out these fabricators of data. When I was in Santiago, Chile, last year, I discovered that someone I thought was a friend and a colleague had made up an experiment that I had allegedly done. And he gave web links to me in Oxford. And when the head of my department heard about this, he ordered him to take it off the website. And he failed to do so. So eventually, it turned out that only the threat of police action made him finally take it off the web. I met him and half a dozen of his friends outside a pub at midnight in Santiago, just by chance. I was walking home, having had a very nice meal, and I said, Justin, I really would like to talk to you. And he said, I'll just be back, I've just got to do something. And I said, no, hang on. I know you now. You're not going to go running off. You're going to tell me why you put that paper on the web. And then, a moment later, I was pinned onto the boat. Half a dozen of his friends were on top of me. I struggled like crazy, of course. My arms were really bruised the next morning. And I received a kick in the leg, which later developed into cellulitis. And my legs swelled up to twice its size. So it still annoys me. Right, so your results are preferably just simple statements supported by either tables or figures such as graphs and the statistical values. Never duplicate results presentation. If you say it in the text that the rats at 50 minutes per kg, sorry, milligram, did such and such, do not represent that again in a figure or table. Highlight the most important results by putting them in graphs to make a visual impression. Save relegate the less important details to the text. So sometimes people put in more data, but this might be best put in an appendix. Most journals just don't have the space, and anyway, group values are much more useful. State whether these are means, medians, or modes. Average is not a quantitatively meaningful scientific term. And you should, of course, include a measure of variability. If your data is parametric, you can use the standard deviation, or better still, the standard error of the mean. Whereas if your data is non-parametric, and most behavioural data is non-parametric, you should use the interquartile range. Who doesn't understand the terms I just used? The mean is the arithmetical average of the data.
Not just the term. You said
The what?
no, after you said something
Interquartile rings? Interquartile rings?
Right. Okay. So, if you have a series of values, hold on. So if this is your parameter, the measure you are taking on the y-axis. So these represent individual raw data points. This is non-parametric data. If you put out the distribution, what's happened is that you have a high concentration at the top end, then very few data points, and then a massive peak at the end, a binodal distribution. That is non-parametric data. Whereas if you have a smooth inverted U distribution of raw data, with most data points concentrated in the middle, that is parametric data. This is a Gaussian curve. After the French statistician, Dr. Gauss. Most behavioural data look something like this, or perhaps a skew to one side like that. And you may even have a few outlying points up here. If you take the arithmetical mean of that data, it will be something like here. That's the average response. But these figures dramatically distorted if you have one or two outliers of 1 million. So the mean of 3, 2 and 1 is 2. Whereas if you have 1 million as an outlier, the arithmetical mean will be 900,099 or so. Not representative. So if you have outliers and high variability, that will not be representative of the group as a whole. I hope that's made things a little clearer. I haven't got time to go into that in more detail now. Okay, so the discussion should start by a brief summary of the results. For example, activity was higher in the rats with hippocampal, but not cortical lesions. The actual values and their statistical significance should be in the results. So many readers don't bother reading the methods of results, and so a reiteration and a summary of those results is very useful at the start of the discussion. You set the context for the discussion by presenting your data in brief. So then, in your discussion, you have a more detailed examination of results. You note inconsistencies or correspondences within the present experiments and in comparison with other scientific work, citing references. Do the results fit the theory? And if they don't, was this due to the way they were obtained? I.e., did your methods differ? Or does the theory itself need modifying? You close the discussion with general conclusions and suggestions for future work. At the end, you have the references, which set the context of your experiment, and they will follow a very strict format according to the journal. And almost all journals differ in the way they require the references. Some will say if there's more than 6 authors, you should put the first 6 authors and then et al. Others require every author to be listed. If you're quoting a reference in, for example, a conference poster, it's often sufficient, like Emily pointed out yesterday, just to put the first author's name, brackets 2002, science. So that you should have enough references to provide your scientific context, to justify your statements, or to cite alternative views. References should be sufficient, but not superfluous. Don't put too many in. If you cite a review or a more recent piece of work on a topic, you can keep the numbers down. So try looking at the sample reports in a selection of journals and consider how they're structured. That will give you a sort of mental template for how to write your paper. Is the information presented in an accessible, comprehensible way? If you need to check on a detail the method or results, can you easily go back a page and answer the question? Behavioural Brain Research is a journal I publish a lot in. I like the style because it is abstract, introduction, methods, results, blah, blah, blah. And if you want to check on the method, you can go back to section 2.1, passive avoidance testing. That will tell you how the passive avoidance testing is done. Very easy to get straight to the point. You don't want to hide a vital detail in a place where people can't find it. Scientists are busy people, and they may not read the methods in detail, but they expect to be able to quickly locate salient, important points if necessary. And the clear abstract, which highlights the essential features of the work, will show up during a lecture's research and is more likely to be read or cited. With rather simplified, I have an even lower tolerance level than normal. So as a student, if you write up well, it will demonstrate explicitly that you understand the issues, and you'll get a good mark. As with an interview, there's no point being clever if you don't show it. As a working scientist, publications are vital to get the message and name known for your curriculum vitae and any future grant applications. At both levels, there are accessible summaries of past work and guides to future studies. However, there is a sting in publishing, and that's when you get the reviewer's report from your peers. That's the beauty of science. You expose yourself to criticism from the rest of the world, and only rarely is the paper immediately and unconditionally accepted for publication. It's happened to me once or twice, and it's a really good feeling. I remember a cartoon from a scientific journal. The editor is talking into a telephone, and he's saying, yes, sir, yes, sir. Yes, doctor, I know it's been a little while since we received your manuscript, but he's making it into paper planes. It's a little while since we received your manuscript, but I'm looking at it even as we speak. There's a very confused Egyptian at the other end of that line. I hope that serves them right. But the worst case scenario could work something like this. Now this is the funny bit to keep you awake. The reviewer's report says, reject out of hand. The study was poorly conceived, badly executed, and the presentation of the manuscript leaves a great deal to be desired. Indeed, I am surprised that an editor of a journal of this quality decided to send it to me for review. Its only redeeming feature was that it was appalling from the very start, and I therefore feel I can confidently recommend its rejection without reading much of it at all. Life is generally not so terrible, and the more likely response will be that something like the figures need to be better labelled, the aims of experiment 3 need to be clarified, and the discussion shortened. Also, the author should note that the paper by Green and Deacon that they refer to does not, in itself, establish the validity of their technique. The more recent work of Deacon and Jenkins, 2002, does, however, and I am greatly surprised that the authors are not aware of the importance of this publication. So if you decide not to commit suicide after this terrible review, you've got the alternative of sending the manuscript to a less reputable journal, such as the Baltic Journal of Laboratory Animal Management, where it will probably be totally ignored by the rest of the scientific community, which you had the juvenile delusion to think you were a part of. However, you may convince yourself, poor fool, you really do have something to report to the world. In this case, you might write to the editor, politely and gently pointing out that since the paper had sent to the reviewing board of a farming rather than a pharmacy journal, undoubtedly an clerical error not directly attributable to yourself, sir, would an additional review be possible? Or if certain new experiments were done and the presentation of the paper included, might it be re-reviewed? So, after reading the reviews, you will scuttle subserviently back to the library, marvel at the astounding insights revealed in Deacon and Jenkins 2002, and try to correct the error of your ways. Take a deep breath as you slip the revised manuscript into the out tray and try to occupy yourself meaningfully for the next 4 months. This is what T.S. Eliot thought. Ridiculous, the waste, sad time, stretching before and after. So, you spend so much effort trying to get this publication, and it ends in failure, perhaps, or you have to send it to some stupid little journal that no one ever reads. So, finally, a little philosophy. There was a scientist who was rather fond of apples, and he wrote such extraordinary works, especially the Principia Mathematica, in Latin, of course. And this is what he felt, reflecting at the end of his long and successful career which influenced the whole world until Albert Einstein came and corrected in a minor way, rather radical way actually, his theories. I sometimes think I'm just like a little boy on the beach. I pick up the bright pebble and then discard it when I see a prettier one. And all the while, unnoticed, the great ocean of truth rolls around me. That, of course, was Isaac Newton. Thank you.